Hello, my name is Ryan, and in this video we will be going over the different auto-grading options available in PrairieLearn, a high-level overview of our documentation. We will be going through number 17 here, this video, auto-grading options. A quick overview of what will be covered in the video is 1. Setup for auto-grading, 2. The auto-grading option using standard output, and then 3. The auto-grading option using unit tests and the check framework, and going over an example problem that's already been made using those two options. So first, the setup for auto grading. Here's an example info.json where you need to set up external grading. This was shown in the previous video, but I will show how it is set up in the examples later. You need to add a test directory to your questions directory. You need to add a Python file named test.py to the test folder, and I'll show that later as well. So the first option that we're going to go over is auto grading using standard output. This option would allow you to make tests that have an answer code, and then you would take the student's code and compare it to the answer, and based on if the test passed or failed, you would output that, and then you would make a standard output that it would test against, and if the two outputs match, then the student would have got the answer correct. I'm going to jump over and show a problem that we're going to go over, a finished version of it. So in this problem, the student is asked to write code that will return the maximum number of consecutive ones in the variable that is passed to the function. So starting off, the HTML here just contains text, a PrairieLearn code with an imported C file to show this, and then a file editor with code inputted as well. And I'll go over that now. So here's the HTML. Here's the text that's written in. This PL code element is the top part with this source file max ones here. Max ones just contains the structure of the problem, and then a PL file editor. This is important for when you're setting up your test.py. The file name that you want for the student's code. Here, the name is just studentcode.c, and then it imports the source file initial code.c, which is just the function that they're going to be writing. And then you want to make sure you have a submission panel with this external grader results and the file preview, so that the students can see, for the file preview, they can see what they wrote, and then this will grab the grading results. So first, since this problem was already done, you would want to first create a new folder and name it test. In the test, you just want to create a test.py file. Here it's filled out. I'll go over more what it means in a second. So first, after you set up I should say, and then in your info.json, make sure you set up external grading. So first, after you set up external grading, you want to add a main.c with a main function to your questions test directory. So here you just make a new file, name it main.c, and just start off by just adding a main function. Second, in your main.c file, you want to declare the function or functions that the student will be implementing. An important note here is you don't want to include the C file where the function is, as it will not be able to, it will cause issues. So if we go back to the problem, the function that the students will be implementing is this max consecutive ones. So in our main.c file, we want to add a declaration of this max consecutive ones, which is done here just above your main. And there's no including of, you do not want to include this initial code.c in your main.c. It will cause issues. Next, you will want to implement the test in the main.c file. So if we expand what is here in the main, this first part here, is required. This is just for setting up the standard output so that a student couldn't just write the print out the answers to standard output, such as this problem requires like test 1, test 2, test 3, test 4, test 5 passed as the standard output. This code here will allow a student not to be able to just print that out. They have to be able to create the function, and the function has to be able to print this out correctly. So moving on, we create a list here of different numbers to pass to the function for testing. So this for loop will go through and it will test this answer code with the variable versus the student codes with the same variable, and print out pass test 1 or test 2, test 3 passed, or if it failed and the student code was wrong or they don't compare correctly, that the test failed. And then finally, you will want to set up the test.py to actually run the test. So now if we go back to the test.py, make sure you import cgrader, create a class, question grader, cgrader.cgrader. Just create a function test. And this is where the name of the student's code is important, as when you go to compile their code, you want to make sure you know the name of the code file that you put in the HTML file editor. So here you just want to put the students that code file. The second option here is the actual executable name. So here it's just student code, and then this add.c file is adding in this main.c so that the function can be ran against these tests. And then the second thing you want to add here is the self.test.run. So here you're actually going to execute the executable you just made, and then here you're adding in the expected output. And then this third option here says that all of the outputs that are output must match. So for this problem, it must print out here test 1 through test 5 passed for the problem to be graded as correct. And then just make sure you make a new question grader and start it. So if we just go back to main.c, just a note, these include statements are now needed for every problem. They're just what we use for this one. And if we take this answer code here and go back to the actual problem and we just paste it in, change this. So say a student did this correctly, click save and grade, and the expected test for tests 1 through 5 passed. The student's function was correct and they all passed. Now if say they made a mistake and had a 15 instead of a 16 here, it will score incorrectly, and you can see it's expected them all to pass. Test 1 failed, but test 2, 3, and 5 passed, and test 4 failed, so they weren't all the same. If you didn't want that to happen, you just have to change the match all expected outputs to false, and you could grade it differently. So that's it for the standard output example. So the next one is auto grading using unit tests and the check framework. First, we're going to look over the finished problem that we're going to go over. In this problem, the student is asked to initialize the ports based on the configuration shown in this diagram, where the diagram can change each time you create a new variant. So a little bit more complex of a problem, but a similar steps to set up. So first, you'll want to start with adding main.c to your questions test directory again. So if we go over to this we have a test directory here, there's a little bit more in it, but you can just add the main.c and the test file again, and make sure the info.json is set up for external grading again. Second, you want to include the checks.h file in the main.c. So if we go back to the main.c, just minimize this for now. You have this include check.h. It may show up with a red underline that it has an issue, but once you actually use it, there won't be a problem. Shouldn't be a problem anyways. So third, again, you'll want to declare the function that student will implement, and making sure that not to include the C file where the function is. So if we go back to the problem, they're going to be implementing a function called init ports. So in our main.c, we want to make sure we declare the function that they will be using. Next, you're going to want to create the test using the start test and test macro that the check.h library provides you, and then give the test a name for its parameter. So if we go back here, we have a test case for the ports. You just do start test, give it a name, so test init ports, and end it with an end test. If we expand this out, what's going on here is the student's init port function is being called, and then there is assert functions being called on the different registers that they would have had to set. And then these are the actual answers that they should have had. And in this included registers.h file, there are the ports that they can use, and that registers.h file is included in the init ports function. So they just have to use the registers and set those registers. They have shared access between those. So an important note is that that problem creates a different problem every time you refresh it. So how that's possible is in this server file is it generates the init ports code file, the main file, and then here throughout it randomly generates the different parameters and also writes to this JS file, which is the picture that you see here, and then it passes the answers to the main.c file part here. Next, you want to create the test suite and add the test, or if you have multiple tests, to the suite, and then eventually you will run it. So if we expand the main function here you just create the test suite, give it a name, then you have to create a test case with this tcase create. You can just give it another name, and then you want to add the test case. So take your variable here, and then take your actual test and add it here, and then you want to add the test case to the suite. So take the suite variable you just made and add it here, and then the test case that you just made here, add it there, and then lastly, oh, I guess I didn't add that. You'll want to create a suite runner to actually run the test, or to run the test. Run the test here, and just have it with a check normal, this check normal flag, and then finally you want to free up the memory from the runner and then return. And then finally here, setting up the test.py file. So if we go back here, again, just make sure you import cGrader, create a class, make it a function named test, and again, compiling. Make sure you have the same name as the PL file editor here, so make sure you make it studentcode.c, and make sure you have this submission panel set up again. So back here, create the executable name here, make sure you add your main.c file. This part here is not necessarily needed, but if you have files such as a .h or other files that this will help with compilation. And then you must add this package config flags, and then you want to have the check because that is the check.h include that you have here that allows that to work, or it tells PrairieLearn that you were using it with check. And then finally, just do self.run check suite and then execute the executable that you made, initiate the class, and start it. So if we go back to the problem, I'm not going to input the answers for this one just because it changes every time. But I'll show you that if you go to the main.c now, here's the answers for the current one, which was that one. And if you have a different variant and go back to the main.c file, there's going to be different answers. But yeah. So that's it for this video. In the next video, we'll be learning how to create a Docker image.